today we will discuss about discrete Fourier transform. Now, what is discrete Fourier transform? It is basically a very powerful tool by which we can perform signal processing in digital computer. Now, before going to discuss discrete Fourier transform, we should have an idea what is discrete time Fourier transform. What is that? Suppose we have a signal x of n. If we perform discrete time Fourier transform, we have x e to the power j omega. This x e to the power j omega is basically a continuous function of omega with a period of 2 pi. Now, if we again sample this frequency, this continuous function of omega within this period of 2 pi, 0 to 2 pi, and if we take n number of samples, then we have DFT. So in clearly we can say that the DFT is obtained by sampling one period of the Fourier transform of a signal x of n at a finite number of frequency points. So this is the simple definition of DFT. So mathematically we can say that x of k, which is defined over x e to the power j omega at omega is equal to 2 pi by n k, where k varies from 0 to n minus 1. That means we are taking n number of samples. So this is the formula of DFT. Where n varies from 0 to n minus 1 and k is also varies from 0 to n minus 1. So x of n multiplied by e to the power minus j 2 pi k n by capital N. Here this small n is basically called time index and small k is basically called frequency index. Now from the formula of DFT we can directly calculate the formula of IDFT also. It is very simple that we can write down value of x of n from this equation, which is 1 by n, k varies from 0 to n minus 1 and n is also varies from 0 to n minus 1. So this is the formula of inverse discrete Fourier transform. Now, so this is the formula of x of k, that is called DFT of x of n equal to 0 to n minus 1 x of n e to the power minus j 2 pi by capital N nk. Now this e to the power minus j 2 pi by capital N can be written as Wn. This Wn is basically called, a new term we will introduce here, it is called Twiddle factor. So this Twiddle factor have some basic properties we will discuss. Okay, so I have solved some examples of DFT. Please go through that. And as we say, x of k is also periodic with a period of n. Obvious, it is very obvious. Now directly go to the concept of Twiddle factor. As I said that Wn, which is defined as a Twiddle factor, is equal to e to the power minus j 2 pi by capital N. If I take mod of this, the magnitude of the Twiddle factor is 1. So it's very simple, and angle is minus 2 pi by n. How are you going to calculate the angle? It is nothing but this x minus jy. So minus tan inverse y by x. Okay, by this formula we can calculate the phase angle of the Twiddle factor. Okay, clear? So this is the formula of DFT. This is basically, this Wn is basically called Twiddle factor, and Twiddle factor having the certain, this magnitude is 1 and phase angle is 2 pi by n. Now this Twiddle factor have two basic properties. I will going to discuss what is that. The Twiddle factor has two properties. One is periodicity property and the second one is symmetry property. So what is that periodicity property? Okay, we will discuss this periodicity property and explain this periodicity property and symmetry property with the help of this diagram. Now how I obtain this diagram? Suppose this Wn is periodic, Twiddle factor to the power nk. This nk is termed as a small r. We assume that small r is equal to nk. Okay. Now If I take n equal to capital 8, that means we are taking 8 number of samples, and we assume also that value of r is taking from 0 to 16. Okay, so value of r small r is basically multiplication of nk. Now if we look into this table, we put the value of r as 0, so that means, and we take capital N equal to 8, so Wn to the power r, so Wn means capital N, that is W8 of r. W8 of r, basically it is e to the power minus j pi by 4 to the power r. Why it is e to the power minus j pi by 4? Because we know Wn is equal to e to the power minus j2 pi by n. So if I put n equal to capital 8, if I n equal to capital 8, it is e to the power minus j pi by 4. So that is the reason it is e to the power minus j pi by 4 to the power r. Okay, and we write down its phase angle as well as magnitude. Now if we do that, if I do for r equal to 0, r equal to 1, r equal to 2, r equal to 3, or subsequently we put all the values of r and we calculate the phase angles, we will get for r equal to 0, we will get W8 to the power 0, it is nothing but 1, and its phase angle is 0, very obvious. If I put r equal to 1, it is W8 of 1, that means e to the power minus j pi by 4 to the power 1. So if I expand this in cos and sine, that is if I apply Euler's theorem, so it is cos pi by 4 minus j sin by 4, this is 1 by root 2 minus j 1 by root 2, and its angle is tan inverse b by a, so it is pi by 4. So by doing this and putting all the values of r, we can calculate the different phase angles of this Twiddle factor, and by doing this we can construct a circle of this. This is basically, so this is basically W8 of 0. Okay, now W8 of 0 is phase angle is 0. Next one, if I put r equal to 1, its phase angle is minus pi by 4, so it will rotate in anticlockwise direction, rotate in this direction. Okay, rotate in this direction, so this is nothing but W8 of 1. Okay, the next is again this is minus pi by 2 with respect to the first one, so this becomes, this is nothing but W8 of 2, this is nothing but W8 of 3, W8 of 4, W8 of 5, W8 of 6, W8 of 7. Okay, and all the magnitudes is 1, as we know that mod of this becomes 1. So first we will discuss the periodicity property. Periodicity property means, see, W8 of 0 is equal to W8 of 8, W8 of 16, means it is repeated after 8 samples. So W8 of 0 is equal to W8 of 8, so and then it is equal to W8 of 16. So in general we can write down WR is equal to WR plus minus n. Plus minus n, that means it is equal, so capital N is the periodicity of this Twiddle factor. Okay, from this diagram it is very clear that W8 of 1 is equal to W8 of 9, W8 of 2 is equal to W8 of 0. So this is called periodicity property. And what is symmetric property? It is very interesting that W8 of 0 is just minus of W8 of 4. See, W8 of 0 is minus of W8 of 4. Similarly, W8 of 1 is equal to minus of W8 of 5, just opposite to that. So it is this property is called symmetric property. In general, we can say that this is the symmetricity property. So these two concepts of Twiddle factor, symmetricity and periodicity, is very, very important in case of discrete Fourier transform, because we will go to use this property for further calculation of FFT. In the next class, we will discuss about the concept of zero padding, as well as we will perform some numerical examples of DFT. Thank you.